Welcome everyone. I would like to present the course that I give for the master course in applied mathematics. The name of the course is Game Theory and my name is Chiara Mocenni. You can find my email in the website of the DIS. And so what is this course? This course is essentially an introduction to game theory and also to evolutionary game theory. Game theory is essentially a mathematical theory which has been introduced to model the decisions of players in situations where there are other individuals that are taking the decision at the same time. So it is grounded on the idea that each player will try to maximize his own payoff, but the outcome of the decisions will depend also on the decisions of the other players. So this will often introduce mechanisms of competition or cooperation also among the players. And so the idea is to introduce the basic mathematical tools that allow to find, for example, the solutions of the games. And essentially the solutions refer to the well-known concept of Nash Equilibrium, which is an equilibrium from which no player has incentives to move from unilaterally. So unless a group of people are aimed, or even all people are aimed to change their decision, no player can improve his own payoff by moving towards another strategy alone. Okay, so the idea is to understand the mathematical tools that allow us to describe the decisions of groups, of specifically interacting groups of people or agents in general. And in the second part of the course, I introduce the evolutionary game theory, where essentially we introduce the time dynamics. And so we move from the static approach to the decisions to the dynamic one. And mathematically, this will deal with the presence of ordinary differential equations, or in other cases, repetitive games. So essentially, I would like to talk about continuous time dynamics. And the evolutionary game theory is grounded on the idea that we have some mechanisms in the biological fields that are at work, that the mechanisms are essentially the replication and the selection. There is a third mechanism, which is the mutation, but we do not devote too much time to mutation, but we essentially talk about replication and selection, which is the mechanism for which some strategies are able to survive in a large population of individuals that are playing games continuously among them. There are many, many interplays between the game theory and evolutionary games. For example, all Nash equilibria of the games are also steady states of the replicator equation describing the evolutionary games. And vice versa, there are many more steady state of the evolutionary game equations with respect than with respect to the Nash equilibrium of the underlying games. So all these concepts are studied, or the mathematics are presented into this course for both the game theory and evolutionary game theory. And moreover, we focus in the last part to some recent advances into the evolutionary games concerning the introduction of the graphs in the population, which means that we suppose that people are interacting among them only when they are connected in some kind of, under some kind of connection, like a friendship or other kind of connections. So there are some results that recently have been found in the literature, and something that we also work on actually. Specifically, I work on cooperation emerging in evolutionary games on graphs with my group. And so at the end, we propose also some research questions to deal with, and students can give the exam in a standard way, or alternatively, if they are interested into more open problems like tackling quite research questions, we can also work together to develop new insights into the theory. That, for example, this year I have worked with the students in a new model, and we have integrated the epidemic models with the evolutionary game theory models in order to study, for example, the behavior of people, the importance of behavior of people with respect to the situations that are emergent, like, for example, the pandemics and other kind of emerging dramatic situations. So I think that there are many interactions also with another course that I give for the same master course, which is the Complex Dynamic System course, that I will also present in another video. So thank you very much for your attention, and bye-bye.